In this lesson, we are going to be looking at how to draw an ellipse. But before we can start drawing an ellipse, we need to go over the basics of an ellipse equation, and then I'm going to show you a basic drawing of an ellipse, and I'm going to explain some important concepts. So the equation of an ellipse goes like this. So it's x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now sometimes the a and the b are going to be switched around, so sometimes you might see your teacher using this equation. So something like that. I will explain the difference between the two as we go along, but for now, what I want you to understand is that an ellipse equation has a plus in between. The next thing I want you to understand is that, well, let's quickly make some notes. So it must be a plus in between. Then these numbers must be different. So the denominators are different. Denominators are different. If they're the same, then it's a circle, not an ellipse. And then the right-hand side, or the answer, or let's just say it must always be equal to 1. Okay? That's what makes it an ellipse. So, for example, if we then go look at some of these examples over here, I want you to be able to tell me if this is an ellipse or not. There's just one more. Oh no, I can add that a little bit later. So don't worry. If you look at this one over here, you notice how it doesn't have any brackets, whereas on the previous slide I showed you that it has brackets. It doesn't have to have brackets. The brackets are just there to show the center of the ellipse. Okay, the h and the k, as we'll see later on, is the center. But if there is no h and k, then the center is simply at 0, 0. So if you had to draw that ellipse, it'll just be at 0, 0 for the center. Okay? So let's see. We said that for something to be an ellipse, there must be a plus in the middle. It must be equal to 1, and the denominators must be different. Denominators different. So the denominators are different. There is a plus in the middle, and there's a 1. So this is an ellipse. Let's look at number 2. There's a plus in the middle, it's equal to 1, and these are different. That's an ellipse. Let's look at number 3. Now, this one is not equal to 1, but we can make it equal to 1 by dividing everything by 18. So we can divide everything by 18 so long. Then we simplify. So if you type that on your calculator, you would see that it will give you 1 over 9. So you can say x squared over 9. You can imagine that there's a little 1 over there. If you had to type this in the calculator, it will give you 1 over 6. So you can imagine it would be something like 1y squared over 6. And then this is equal to 1. Now we can see if it's an ellipse by looking at, there's a plus. Yes, it's equal to 1. Yes, these numbers are different. Yes. So this is an ellipse. Number 4 is not an ellipse because it has a negative in the middle. This one is not equal to 1, but we can make it equal to 1 by dividing everything by 4. And so you end up with, if you had to type that on the calculator, it will give you a half. So that's the same as saying x squared over 2 plus y squared over 2 is equal to 1. There's a plus. It's equal to 1, but the denominators are not different. So this is actually a circle and not an ellipse. What I'm now going to do is just explain h, don't know why that's a capital, we're just going to explain h, k, a, b, and c. So remember in the formula we said x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So we're going to quickly go through what h is, what is k, what is a, what is b. Don't worry about c, I'm going to explain that to you shortly. I know you can't see any c at the moment, but there is something that we call C. Okay, and then on this side I'll show you the other form where you'd rather have x minus h over b squared. Remember I said that there's 2 different forms that we use. Right, so let's have a look. So the first thing I would like you to realize is that, well, the first thing I want to tell you is that the a is always bigger than b. Okay? A is always bigger than b for both scenarios. The a number is always bigger than the b number. Now, can you see for this one, the a we said is a bigger number. Now this a is with the x value. Can you see that? It's with the x value. What that means is that this ellipse is going to look like that. It's going to be horizontally stretched. Okay, so it's going to be that kind of shape, whereas here the A, which is the bigger number, is with the Y, so this one is going to be vertically stretched. Okay, that's the first important thing I want you to understand. The next thing is that the center of the ellipse will have the coordinates of, let me actually make a nice big ellipse. Okay, so the center is always going to be H and K, and that's true for this one as well. The center is always going to be H and K. Now, if you look along this line, that is the longest line, so that's called the major axis. So the long one is called the major axis, and then the shorter one, the shorter line, is called the minor axis. Okay? Now, these parts over here on the major axis, on the two ends, those are called, each one is called a vertex, but if you're calling both of them, we call it the vertices. Okay, so those are the vertices. So the vertices of this one would be up here and over here, because they're always at the end of the major axis. So these are the vertices. Or if you're talking about one of them, it will be the vertex. Now these parts over here, which is on the ends of the minor axis, they are called the covertex or the covertices. If you're talking about one of them, it's a covertex. If you're talking about both of them, it's covertices. And then on this one, it would be over here. All right. The next thing is the length from the center to the vertex. That distance is what we call A. That distance is A. Of course, it's the same on the other side. Okay? And then the distance from the center to the covertex, that is what we call B. All right. So here the A would be this one, because it's always from the center to the vertex. That would be A. And then from the center to the covertex, that would be B. So the B is always the shorter one, and that's why I said, yeah, A is always bigger than B, A is always bigger than B. Okay, that's important. The next thing we're going to talk about is something called the focus. For an ellipse, the focus is always going to be on the major axis, and it's usually going to be, well, it's always going to be somewhere between the center and the vertex. So it's going to be somewhere over there, for example, and then there'll be one on the other side as well. So that is called a focus, okay? If you are talking about both of both of them, then you won't say the focuses. You'd rather say the foci. So your teacher might have used the word foci. So for this one, the focus would be somewhere over there and over there. It's always on the major axis, not the minor axis. So the distance from the center to the focus, that is called C. Okay? So from the center to the focus, that is called C. Now to calculate C, you could use the following formula. So let's use the focus formula, which is C squared is equal to A squared minus B squared. Okay, that is the formula to calculate the focus. And that's the important things we need to know. Now on the next couple of slides, well, just after this, in the next few minutes, we're going to be talking about, well, I'm going to show you exactly how to draw them. So we've got quite a lot of examples where we are going to put this all into practice now. So here is our first example. So the first thing I want you to realize with this one is that which one is, well, let's first see that it's an ellipse. It's got a plus, it's equal to 1, and these numbers are different. So it is an ellipse. The next thing is that the bigger number is with the x. So the bigger number is always called the a squared. So this is the a squared. And then this must be the b squared. And because the bigger number is with the x, it's going to be a horizontal ellipse, not a vertical. First step is to always find the center. So the center we usually find by looking at these coordinates over here. Remember we said that the center is hk. But in this example, there is no h and k, so the center is right in the middle at 0, 0. Now, we said that this ellipse is going to go in this direction. So if this is the center, we said that to find this vertex, you need A. To find the co-vertex, you need B. And then to find the foci, you would need the length of C. So we need to go find A, B, and C. To find A, we'd know that A squared is 49. So A squared is 49. Whoa, what am I writing? So then to get A, you would square root, and you would get plus and minus 7. So that means we're going to go 7 to the left and 7 to the right. To get B, we would say B squared is 25. So B would be 5. So we'll go 5 up and 5 down. From that, we can draw our ellipse. There we go. So the vertex and the co-vertex, we can go label their coordinates as -7 and 0 and 7 and 0. That's the vertex. The co-vertex, or the co-vertices, if you'd like, they are these ones. So they are at 0 and 5, and then 0 and -5. The next one is the foci. Now that's the length of C. So to find C, we use the formula. A squared take away B squared. So we're going to say C squared is equal to A squared, which was 49, take away 25, and that's going to give us 24. To get C alone, we take the square root, and we get plus minus 2 square root 6, which is approximately 4.9. That'll help you to see where to plot it. So we know that C is the length from the center. So if this is our center, so we're going to go 4.9 to the left, which is about there, and 4.9 to the right, which is about there. To give the coordinates of that, you could simply say -2 square root 6 and 0. That would be this one, because it's got a y value of 0. And the other one would be +2 square root 6 and 0. And that is it. That is how you draw an ellipse. Now, for the remainder of this video, we're just going to be doing a few more examples. I'm going to do some that are horizontal, some that are vertical. So here's our next example. So the first thing we could do is try to possibly, let's go locate the center. Okay, now we said that from the basic equation, x minus h over a squared plus y minus k squared over b squared is equal to 1. I know that these can sometimes be switched around. I'm aware of that. But for now, I just want to remind you that h and k will be the center. So h would then be a 2. That means the x value of the center is 2. But now look at this, it's a plus. So that actually means that the center is at -4. Because it's normally meant to be a negative. If it's a negative, then everything's normal. But now that it's a plus, it's the other way around. So the center is going to be at 2 and -4, which is over there. The next thing, so let's just go fill that in, 2 and -4. The next thing I want us to identify is whether this is going to be a horizontal, which goes like this, or a vertical, which goes like that. So the way that you do that is you look at the x, and that goes with 4. Then you look at the y, that goes with 9. So the bigger number is with the y. So that means that this is going to be a vertical. So in actual fact, this equation, the basic equation, would have a b squared for that one, and then the a squared for that one, for those of you that are very technical. So we're gonna have an ellipse that's gonna do this. It's gonna be longer in the vertical direction. Okay, let's try that again, Kevin. Whoa. Okay, so we're gonna have an ellipse that does that. It's not gonna be horizontal. So that means that the A is gonna be this one, or you could also say this one, doesn't really matter. And then the B is gonna be that one. And then the C is going to be somewhere like that. Okay? So the A is always on the major axis, the longer one. And then the B is always on the shorter one, which is the minor axis. Okay, so we can go find A and B and C. So A will be from that. So A squared is equal to 9. Whoa, I did that in the last one as well. So A would be positive and negative 3. So that means that we're going to go 3 up. We're not going to go 3 to the side because then it's going to be horizontal, but we want it to be vertical. So we're going to go 3 up and we're going to go 3 down. There we go. Then we can find B by saying B squared is equal to 4. So B would be positive and negative 2. So we're going to go 2 to the right and 2 to the left. Okay, and then we can draw our ellipse. Something like that. So we've got the, I should have actually kept that, but let's go get C. So we know that C squared, we can use this formula, A squared minus B squared. Now remember the A squared is the big number, which is the 9, so that's going to be C squared is equal to 9 take away 4, which is 5. Then to get C by itself, you're going to say plus or minus the square root of 5. And that's approximately, just so we know where to place it, it's about 2.2. So we're not going to go right and left, we're going to go up and down because this is a vertical ellipse. So we're going to go 2.2 up, so that's about there, and 2.2 down. Because remember the focus, or the C value, is from the center. It's that length from the center. And so that would be our focus and our focus. Okay, so let's go put all the coordinates. So the vertex, remember that the vertex is on the major axis, which is on the long one. Okay, so that's going to be this point over here and this point over here. And then the co-vertex is going to be this one over here and this one over here. So the vertex will be at 2 and negative 1. And then the other vertex is at 2 and negative 7. Okay, the co-vertex or the co-vertices are going to be at 0, negative 4, because that's a negative 4. Sorry, I've blocked that over there. And then 4 and negative 4. Then we need to go find the foci. So the foci is over there and over there. Now don't use the decimals. What you can do is the following. Take the center coordinates, which is 2 and negative 4. Okay, and then for this foci, you're gonna take the y value. See, the x values are the same. The x values are the same, but the y value is going to be square root 5 above. So you're going to say minus 4 plus square root 5. Okay, so you might have to just pause and think about that. The x value won't change, but the y value will be square root 5 above. And then the other foci, which is this one down here, is going to be 2 and then negative 4 take away square root 5. And that would be this one down here. And there we've done it. Let's do another example. So the first things we can look at is the x is going with the 16 and the y is going with the 9. So the x is the bigger one. So that means that this is the a squared and this is the b squared. The a squared is always the bigger one. Okay? So if x is going with the bigger one, then this is going to be a horizontal ellipse. Okay? That must make sense. So if we quickly draw a little horizontal ellipse for ourselves, let's do a bigger one. Then the center is always going to be, we've said h and k. Then the length, the longer one is a, the shorter one is b, and then c is the focus, which is sort of like that. Okay, so the next thing, let's go find the center. So remember the center is h and k. So the normal equation goes like this. So if you see that it's normally a negative, but now it's a positive, so it means that the center is going to be at negative 3, not positive 3, negative 3, and then this one doesn't have 1, so that's just going to be 0. So our center is going to be at negative 3 and 0. And remember, when you have it in a bracket, if you say plus, that means you're going to the left. And that's why we've gone to the left, you see? If you say minus, if it was x minus 3, then you would go to the right. The next thing we need to go and do, because remember, this is going to be a horizontal ellipse. So we said we need to go find A, B, and C. So to find A, we just use that. So we can say that A squared is 16. So that means A would be plus and minus 4. So it would go 4 to the right, 4 to the left. There we go. Then for the for the b, we'd have to go up and down, so that would use this one. So we would say that b squared is equal to 9. So if you take the square root, you'd get positive and negative 3. So you'd go 3 up from the center, 3 down from the center, and there we go. We can now draw the ellipse. The next thing we need to find is c. So to find c, we use this formula over here. It's always a minus b, not b minus a. And so that's going to give you 16, take away 9. So that's going to give us 7, and then c would be positive and negative square root 7. So square root 7 is approximately 2.6. So we're going to go 2.6 to the right, which is about there, and then 2.6 to the left, which is about there. Okay, now we can go get all the coordinates. So remember, the vertex is always on the major axis, so that the vertices, that would be there and there. The co-vertex is there and there. And then the foci would be there and there. And so let's go do all of that. So for the vertex, it's going to be negative 7 and 0, which is that one. Then this one would be at 1 and 0. Then your co-vertices would be at negative 3 and 3, which is that one. And then negative 3, negative 3, which is that one. Then what's next? Okay, we've got the center labeled already. Now we need to get the foci. So for this one, you always start at the center. So let's go write out the center. So the center is negative 3, 0. Okay. Now let's just give a bit more space, just in case we need to add anything. Okay, so for this one, you could say negative 3, and then the x value goes to the left, and we said it was square root 7. So we could say minus, well, not for, let's say minus square root 7, and that would be for that one. And then for this one, it goes square root 7 to the right. So you could say plus square root 7, but the y value stays at 0. And that's it. Here's our last example. So this one, the x, the bigger number goes with the x. So this would be, so the bigger number is always your a squared. The smaller number is always your b squared. So because the bigger number goes with x, it's going to be a horizontal ellipse. So if it's a horizontal ellipse, then it's going to have a center over there at h and k. This long line is the a, the shorter line is the b, and then to the foci, that would be your c. So let's go find the center. Now normally the center, well, the center is always h and k, because remember the formula goes like this. Now because there is no brackets over here, it means that your center is at 0, 0. Now we can go find a, b, and c. So to find a, we could say a squared is equal to 9. So that means a would be positive and negative 3. To find b, you could say it's equal to 4. So b would be positive and negative 2. So we're going to go 3 to the right, 3 to the left, 2 up, and 2 down. And there's the ellipse. Now, the vertex is always on the major axis, which is the longer one, so there. The co-vertex is on the shorter one, which is there. And then the foci is... oh, we didn't even put the foci. Oh, because we haven't even worked it out. Silly me. So c squared is equal to a squared minus b squared. So c squared is going to be equal to 9 take away 4. So c would eventually be the square root of 5. Positive and negative. Now, square root 5... is approximately 2.2. So we're going to go 2.2 to the right of the center and 2.2 to the left of the center. Okay, so let's go get all of our coordinates. So the vertex, the yellow ones, will be at negative 3, 0, as well as 3 and 0. The co-vertex, which is the green ones, would be at 0 and 2, and then 0 and negative 2. The foci, so let's go write out the center, which is currently at 0, 0. Now, if you look at this foci, it's going to be square root 5 to the left for the x value. So you can say 0 minus square root 5, which is negative square root 5. That would be for this one. And then for this one, it would be square root 5 to the right. So that would just be square root 5. But the y value would be 0.